Hello everyone, welcome to the session. So in this video, we will be discussing about the difference between R square versus adjusted R square. So basically, if you will be able to observe, until so far, we have covered up the complete concept behind the linear regression, right? And here comes a very important part that let's say ki you have built a model on top of a given data set, which basically tries to maybe predict a house price or maybe any regression problem, right? Now, the final task is just to evaluate that model, that how good that model is performing, right? How better predictions that model is able to give to us. So that's where the important matrix is R square and then adjusted R square. We will talk about the difference between these two because a lot many number of times you will observe that in an interviews also this question can be asked from you. So I will talk about mathematically how it will be computed, and as well as I'll talk about the layman term, what is the literal meaning of this two evaluation metrics that we have. Afterward, in the upcoming sessions, you will observe that when I will go for the implementation of this house price prediction, I will take both of the metrics and will try to show you how we will be able to compute the value of R square and the adjusted R square. So please stay tuned and let's get started with the difference between these two. So let's say that we will be having a data set, and because in the upcoming session we will try to do the implementation of house price prediction, we will take that example only. As of now, let's say ki I will be having maybe size of my house, maybe it's a 2 BHK or 3 BHK or 4 BHK, depending upon that. There is a price, and this is a data set which is given to me. Okay? Let's consider that this is a kind of a data which is provided to me. I have only single feature. So here I am talking about a simple linear regression. I hope now you know about all these concepts as well. So here we will be having x's, and this is the y value which I want to do the prediction for, right? This is the y. So y factor is there. Now, what we want to do in a linear regression is we just try to plot a best fit line depending upon what is the input data points that we have, right? What is the input data points that we have? Let's say okay, this is the data points that we have. Depending upon that, we will be able to create this kind of a best fit line. Now, whenever we are talking about evaluation metrics as R square, before talking about that also, if you remember, I have talked about something called as residual in my linear regression conceptual understanding part, which is also known as an error term. Do you remember that? And what we have understood that the simple literal meaning of this is the difference between the actual value and the predicted value. Whatever be the difference between these two, we usually call it as a residual or the error. And in order to do the summation for all the data points that we have, we will be able to get the cumulative residual or cumulative error term that we will be able to have. And what we really want to do in the training part, we really want to optimize the value of this M and C. I think complete maths I already have talked about, but just to give you a brief overview, we really want to optimize this value of M and C, slope and the intercept, so that we will get a minimum residual. So whenever we are training our model, I told you that literal meaning is we are trying to find out these parameters, these optimal values of M and C, right? Now, basically, whenever we're talking about this R square, this is the formula to calculate the R square, which is 1 minus what is the sum of squared errors, right? With respect to the residual, sum of squared errors with respect to the residuals, or I'm saying errors also. So you will be able to understand what is the meaning of error, divided by total sum of square. Total sum of square. This is the general formula which you will observe in various websites. You will be able to see this particular kind of a thing. So what this particular thing, try to explain to us. When I'm saying residual, you clearly understood the difference, right? For example, let's say ki, for this data point, this is the y value. For this size of my flat, this is the y value. Let's say ki the size is something, okay. And here the, let's say, price equals to, it can be, right, 50 lakh. This is the price that we are getting. I am giving just random here just to make you understand what I'm trying to convey. What is the predicted value here? What is the predicted value here? Let me try to take some different color. Let's say this one. And here you will be able to observe. This is the gap, right? This is the gap which I think everyone will be able to understand. This is what we call as a y cap. And this is what we call as a y. And this is the gap which we are saying it as a residual or an error. So when I'm saying sum of squared, what we are trying to do is we are saying 1 minus the value of y minus y cap whole square. So that we will be able to nullify that negative value. It might be the case that at some point of time, we will be having y cap bigger, and at some point of time we will be having y bigger. So to nullify that negative effect, we are doing a squaring of that. Okay. Now, because we are looking for all the data points that we have, so I is equals to 1 to n. I is equals 1 to n. So this is what we will be able to get, divided by total sum of squares. Now, what is the meaning of total sum of squares? Here we are trying to find out the average value. Okay, we are trying to find out the average value, and this is nothing but y bar. So what is the difference or the gap between the actual value and the average value of y that is something we are including in the total sum of squares value. So it will be summation of I value equals to 1 to n y minus y bar whole square. So this is something which I will be able to say as the way to calculate the value of r square. Now, if you will be able to observe, let's say कि your sum of squared error is very, very high. Let's assume that your residual value is very, very high, means the difference between the actual data and the predicted data is very, very high. Then what will happen? Very, very high, comparable to even the total sum of squared error also. Total sum of squared error also. This is higher term. Then what will happen? Your complete, can I say this division thing, this particular complete I'm talking about will be very much bigger. Can I say, everyone? I think this simple maths you will be able to, what I'm trying to convey. This part will be if my of square error will be bigger. And if the complete value will be bigger, right? In that case, if you're doing the 1 minus that bigger value, your r square value will be lower. I hope it is clear to everyone. What I am saying is, if let's say your numerator, which is the sum of residual errors, is bigger value as comparable to the total sum of square error value, your overall term will be bigger. For example, 10, 5, right? 13 by 1, 13. So basically the division will give you a bigger quantity. And when you will do the subtraction of that bigger quantity, 1 minus that bigger value, you will be able to get a smaller r square. In that case, you will be able to get a smaller r square. The question is, do we have a scenario? Because in interviewer can ask you that, are we expecting a higher value of r square, or we are expecting a lower value of r square? So your answer should be that we are expecting a higher value of r square, not a lower value, because just now I have told you, when this will become smaller, the residual error will be bigger, and I never ever want this value to be bigger, right? So in this scenario, never want. As an ideal case, this scenario should not happen. So we never expect this kind of situation. What we want is a bigger value of r square. So r square will vary from 0 to 1. Okay? And what is the meaning of 0? When this complete quantity will be equals to 1, means you will be having a maximum residual error. That is where your value of r square is 0, and you will be able to get a model is very badly trained, right? You have to improvise more on your model by increasing the number of independent features, or maybe by reducing the overfitting if your model is having. So first of all, you have to look upon it, the value of r square, and accordingly you will judgment that how should you improvise that number. You always want your r square value as per the researchers' research. Usually, it depends on the kind of data we are using, but it's expected that your r square value is bigger than 0.7 or 0.8. This is what our expectations should be. This is what our expectations should be. Now, when I'm saying that r square value should be bigger, What is the meaning of that? Again, try to understand. When I'm saying when this complete value will be big, when this value will become smaller, and when this will become smaller, when your numerator will be very low. And that is what we want. We want our residual sum of error will be as low as we can maintain, right? Then able to get a very smaller term. And when you subtract 1 minus with the smaller term, you will be able to get a bigger r square value. And that is the real intuition which we want. We want a minimum residual so that we will be able to get a bigger r square. So I think that now you will be able to understand that how this r square is impacting a lot in order to get the evaluation value of the regression model, right? Now here comes something more interesting. This is the talk about the r square, which is one of the very performance metrics. By the way, both of them are the crucial, I would say, performance metrics that we have in terms of the regression model. And it is only about the linear regression, be it any regression kind of problem you are solving, you can measure this thing, right? Now let's try to talk about something called as a adjusted r square, which we usually evaluate the value of r square. So the formula to calculate the adjusted r square is 1 minus 1 minus r square 1 n minus 1 divided by n minus p minus 1. This is the way to calculate a score adjusted r square. Now, what is this all about and what is this n? So r square term, I hope you will be able to understand. This is the above formula only, with the help of which we will be able to get some number, and that same number we are using here. This n is the number of data points that you are having in your complete data set. Number of points that you are using. Then P is the number of independent predictors that you have. Number of features that you have. Predictors or features, whatever you can. Now here try to understand there is a need to calculate adjusted r square, what it is doing. First of all, let me try to explain to you in the terms of layman. Okay. For example, let's say same problem. I want to predict a price of a house, and in future I will be having more independent features. For example, just now I have talked about that I have single feature, maybe size. But in future, let's say I will be having more features like the location of a house, maybe what other things we can say, maybe the number of bedrooms that we will be having, maybe the number of washrooms that may be having. What you will be observing that because all these features are very important and crucial factors in order to predict the price of the house, what you will that these features will genuinely help my model to get a better prediction of the house, right? And as and whenever you will increase the number of independent features, you know that the value of r square will also increasing. Initially, maybe let's assume when you are using a single feature, you are getting maybe the value as point, let's say 65. I'm just giving a random number. By increasing these many features, your value of r square might be increased from 0.65 to 0.85 or 0.75. Means there is an increase in the value of r square because the residual error will be reduced somehow as and whenever you will increase the number of features, which basically helps the model to get a better prediction. Okay, this is fine. Now in this case, if you will be able to observe, even if you will apply the formula of that adjusted r square, this is the mathematical formula which I have just now given you, you will observe that even the value of adjusted r will also be increasing. Adjusted r square will also be increasing. That is good, right? And this is what we want. We want a good number of adjusted r square also and r square value also. But now a twist. What is that? Let's say that apart from this feature, which is size, x1, x2 location, x3 bedroom, x1, there comes a new feature which is, and this feature is something which is gender. Let's assume in that house price prediction, I will be having a feature now, the name of gender. Now what will happen? By increasing again the feature, your value of r square will further increase. Because your r square value is not a sense gender feature will really be helpful in order to do the prediction of a house price, right? It's not valuable. Whatever the gender is, whether it's male or female, how does that impact my price of a house? But R square will apply a random formula that just now we have discussed and will give the number. But this values, we are doing a division by this number of independent predictors, and as we are increasing, so what will happen is your value of adjusted R square, not that much of valuable feature or predictor that we have, what will happen? It will decrease. So it penalizes the value because of having an inclusion of that feature which doesn't make a sense in order to get the prediction right. So by saying that, at any point of time, if let's say you in a given data set, if you will be having a few features which you think will not be enough valuable to participate in the prediction of something, for we had talked about house price, in that case adjusted R square is a better metric as comparable to the normal R square. At point of time you will observe, as in whenever your number of features, your R square value will anyhow increase, but your adjusted R square value will get penalized, because here what we are doing, we are saying whatever we are doing a subtraction by 1, then number of data points minus this important thing help that value to penalize. If you will be able to observe, we are doing just p minus. So as your value of p will increase, so it will do a subtraction, overall that value will become very very low, and at that point of time very very high, and at that point of time when you will do the subtraction by 1, you will be able to get a lower value of adjusted R square. So this is the overall idea behind R square versus adjusted R square. So now I hope that you will be able to get a clear-cut idea behind the concepts of R square versus adjusted R square. So what we will do in the upcoming part of the session, you will observe that now whatever I would say mathematical intuition you have learned so far, we will try to do the implementation for the same, and we'll try to see that whether whatever concepts we have understood will make sense while doing the implementation or not. So bye bye everyone, happy learning to all.